There we go. So the first point to make is that regardless of what industry you are coming in from, whether you are coming in from the government, you are coming in from private, from a large enterprise business or a smaller business, everything we do today is software. And this slide tries to illustrate the idea that whether you are a retail consumer goods company like P&G, or you are in large manufacturing like G&E, or you are in automobiles, you are in the software business. One of my favorite examples is to simply point out that our cars today are really nothing more than computers on wheels. We have to have an engine. We certainly still have a drivetrain, but for the most part, our cars operate on computer controls. And so the software has become the critical component of the improvements that we are seeing in the automobile industry.
Eric, excuse me, but we're not seeing the full presentation.
Are you okay? Let's see if we can. Is that the one?
I'm not sure.
Do you see a full slide?
I'm seeing. There we go. That's it.
Okay.
Thank
Good.
you.
So as I was saying, and then finally, if you are in the, if you're a Starbucks or not on the slide, but a Panera, you are in the business of delivering not just a good, a cup of coffee, a sweet roll to your customer, but creating an experience. And software is the heart behind how Starbucks delivers on that experience to their customers. So everybody, no matter what business you are in the software business, and that's a critical understanding. So then we can move to the next. There we go. So if you have started to adopt Agile, and Agile being the buzzword that was introduced in the 2000s, you may think, well, this is going to replace Agile, but it really doesn't. The point I'm going to make is that we're going to build on your Agile experiences as we move into DevOps. So if you've done Agile, you're pretty familiar with a picture that looks like this. You may have an electronic version, but you may just have a board, a wall in your company, or many of them, where people have got stickies, they've got columns for to do, in progress, and done, and they've got the requirements, and people start to add their notes. This is how modern teams are working today. This is an Agile approach, and we strongly recommend, promote, and train companies in how to use an Agile methodology to get the best they can out of their software teams. This has been revolutionary for the software industry. And what we see when we go out and we do surveys of companies around the world is that 77% of companies, and that's actually a fairly old number, it's probably closer to 82 to 83% today, are reporting that they're doing some form of Agile, whether they're doing Scrum, Kanban, Lean, a combination of those, whether they're doing it correctly or even whether they just think they're doing Agile but they're not. They're reporting that they are doing Agile in some form or fashion, and it doesn't matter which size the team, whether they're small teams or extremely large teams. Agile has really become part of the new normal. And the second part of that is Git. If you're not familiar with Git, Git is a distributed version control system. I'm going to talk a little bit more about Git as we get towards the center or the middle part of this presentation. But what's important to know is that Git, like Agile, has been tremendously important in changing the way software is developed. And as I say, we'll talk a little bit more about why that is. But between Agile and Git, these have really changed the way developers work today. Software teams are doing their job. And this has become, as we say, the new normal for this particular, in this area. However, if you are working in Agile, you have not still gotten over the problem that we have silos that are not being addressed. Developers are all working in their Agile environments on the left-hand side, and then what they're typically doing is throwing their code over the wall to the operations, and they're saying to operations, go and figure out how to bring this up, how to keep it up, how to maintain it, how to back it up, and how to upgrade it, all of the things that operations is responsible for doing. And then finally, on the right-hand side, we've got that silo we call customer service. And our customer service people are truly our front end to our customers. They are the people who are going to field the calls when our customers aren't getting the service that they need, when they have questions about how our software works, whether it's a web page or it's a software we've delivered to them, or it's simply how the product we're trying to deliver to them works. And underlying that, of course, is software. Our customer service people are our first line of defense, and they are the ones who set the tone for how our customers see us. And too often what happens is they have no idea what's been deployed, what's going to be deployed. They have no information on it. They have no insights into what the deployment schedule is. And so this causes a great deal of problems for customer service. Meantime, operations is trying to figure out how to deploy and maintain all of this new software, and development has a mandate to turn out new features, enhancements, new revenue-producing products as quickly as possible, and the three silos simply don't talk to each other. That is typically the world we find ourselves in. So we can ask ourselves some questions. Does this describe our environment? Do we have SLAs, service level agreements? If we don't, one of the most common reasons that I hear from my clients as to why they do not is because they have no way to measure whether they would actually be able to meet the SLAs or not. And they are very concerned that if I publish an SLA, then I'm going to be held accountable for it, and I have no idea whether or not I can even meet it. And if I have SLAs, how often am I actually exceeding the response or closure times associated with those SLAs? If I'm having trouble publishing SLAs and delivering on my SLAs, that's an indication that I need to start thinking in a DevOps kind of way. Is my infrastructure always on fire? Are my operations folks running around in that hair on fire, always a crisis kind of mode, trying to fix the latest problem that has crept up? Are they able to deliver on my 3 or 4 or even 5 nines availability promise, or are they constantly trying to catch up with the latest thing that development has given them, whether it's buggy, whether it simply doesn't match with the environment, and so on? And that then leads to friction between my development and my operations teams. My developers are under that mandate, deliver, deliver, deliver. Operations is under a mandate to make sure it works, to make sure it stays up. And every time development gives them new code, it introduces new risks that operations really doesn't want to have to deal with. And then finally, from a development standpoint, are they able to deliver what they committed to deliver on time, and is that getting deployed and made available to the customers so that you're realizing those new revenue opportunities, which is the whole underlying reason that we're in business at all. If you have started to say, well, gosh, some of these problems that have been addressed really do relate to my environment, then we are talking about DevOps. So, of course, the answer to the question, what goes beyond DevOps, is quite clear. What goes beyond Agile is DevOps. DevOps is what we're talking about, and this is what we want to move to. And I want to take a few minutes now to talk about what do we mean when we talk about DevOps, what are the elements of DevOps, and then I want to look at what are some of the results that mature organizations that have adopted DevOps actually seeing in their own environments. So what do we mean when we talk about DevOps? Now, you may be familiar with Gene Kim's book called the Phoenix Project. This book by Gene Kim is a sort of a novel kind of approach. That is to say, it's a story in which he describes an organization adopting DevOps, coming into it one piece at a time. And the DevOps handbook that we're going to give away at the end of this was written also in part by Gene Kim. So a great resource. But what Gene Kim does is he describes what he calls the rule of three. So the first rule is what we call left to right, moving from the beginning of our development process. We do requirements, we do development, we have to test all of this, we operate it, that is to say we deploy it, and then we have to support it. These are all the pieces, and it's a very standard part of any development and operations life cycle for our software. And what we want to do when we're thinking in our first rule, our left to right rule, is to say, where are our bottlenecks? For instance, our bottlenecks may be between development and test or test and operations. Maybe we're able to develop faster than our testers can actually test the software. Very common problem. Or perhaps we're able to release the software, but operations cannot actually deploy it for 2, 3, 4 months while they're waiting for new environments to be able to be spun up. Maybe they need new hardware, maybe they need a new operating environment, whatever it may be. Operations may be the bottleneck. Our focus when we look left to right is to identify the bottleneck and to address what is causing it. Once we've addressed that bottleneck and that is no longer the thing that's holding us up on moving left to right as quickly as possible, we then look for the next bottleneck. And we just keep doing that because there's always something that we could do that will move this process faster left to right. The second rule is what we call amplifying feedback or right to left. What happens is it's the people to the right side of the process that know what's actually happening with the software in the field, with the problems in operations, with testers who are getting software too late, who are getting software that can't be tested, and so on. And what we want to do when we're thinking about our second rule, our right to left rule, is we want the people at the right to be pushing their information, whether it's incidents coming in from the field, whether it is bugs that are identified by operations and so on. We want those to move from right to left as quickly, as efficiently, as completely, and as usefully as possible. And that means understanding that the people to the right of us are incredibly important to us doing our job. So if I am a tester, I want to know from operations and support which things failed that I failed to accurately test so that I can start building new test cases that are going to catch those things before they get out into the field. I don't know that if support and operations aren't giving me that feedback. If I am in operations, I want to know from the support people, what are you getting calls about, and what are the things that we need to be looking at fast, and how do we, where should we be swarming on this so that our customer satisfaction and our SLAs are met in every case, or at least as much as possible. So this is our rule. Our rule number 2 is right to left, amplifying that feedback, swarming on the incidents, and making sure we're addressing the problems that the right side is finding out. And then finally, our third is continuous experimentation. Do we have a culture of learning? Are we constantly and continuously asking ourselves what went well, and we should continue to do that? What could we do better? What are the things that would be better if we had done them differently, if we had spent more resources, perhaps up front, anticipating some of the problems? What would happen, perhaps, if we paid down some of our technical debt, and so on? Are we continuously asking ourselves, how do we get better? This is the third part of our rule of 3, is not being willing simply to continue doing business as usual, but asking ourselves, how can we do our business even better? One of the real leaders in DevOps has been Amazon. And one of the key elements that Werner Vogels had started preaching right at the beginning is if you build it, you run it. And this gets at all 3 elements of that left to right, right to left, and continuous learning thinking, that rule of 3, or our DevOps thinking. What that says is that the people on the left-hand side are developers, have to be as engaged and as responsible for the software they build as the operations and support people end up having to be when it actually goes into the field. And so in organizations like Amazon, like Atlassian, and many other DevOps organizations, developers are expected to be equal to participate in operations and in customer support, at least sufficiently so that they know their software is running and they get that quick and early feedback, excuse me, and then finally that they are part of the continuous learning that goes on. Everybody from left to right is part of the team, and the team runs this, builds it, deploys it, and runs it together. Okay, so let's talk about a little bit of what do real-world companies see as the results of adopting and becoming mature in DevOps. Now, this is a little bit of an older report, but the numbers that I'm going to show you, as startling as they may be, are accurate, and in fact, we are seeing even greater improvements. First of all, the most mature DevOps teams are finding that they have 5 times lower failure rate when they introduce a new release into their environment. This could be changes due to patches or bug fixes. It could be enhancements or new features, but they are finding that through the DevOps approach, they are 5 times less likely to introduce a failure because they introduced a change into the environment. And for any of us who know the risks and have lived through the nightmares of weekend upgrades, we know that having that peace of mind that it is much less likely that we're going to be up at midnight on Sunday night trying to get this upgrade actually working. This is huge for our operations folks, and it's actually huge for our support people because it reduces the calls that come in to the help desk. Also, when we have a failure, and failures are inevitable to happen from time to time, we find that the most mature organizations are 96 times faster to recover from the failures. And why is that the case? Well, the case is it's twofold. One is changes are much, much smaller. And because those changes are much smaller, fixing the change is much faster. The second is because we are going to automate as much as we possibly can, and so the fix can be automated from development all the way through test and operations to be deployed. And what we're able to see is that we can now turn up that fix, as we said, 96 times faster than a low-performing team is able to do. 440 times shorter lead times. And what a lead time is the time it takes from the inception of either this new code, whether it is to be a bug fix or whether it's to deploy an enhancement or a new feature, to the time it's actually deployed. So from the time requirements starts to the time it actually gets deployed, we are reducing the time by 440 times. Now, what do we mean by this in real types of numbers? What this really means is because we're thinking small and we're thinking in components and we're thinking in well-crafted architectures, we are able to release as often as several times a day, as opposed to once every 6 months or once a year. Now, that doesn't mean you have to deliver or you have to force your customer to upgrade several times a day. But as we know, anybody who has a smartphone, you know that every morning you wake up and you see that several of your apps have been upgraded. And sometimes it's the same app being updated 2 or 3 or 4 times a week. And it's because they're delivering bug fixes, they're delivering new features, and all of this is happening without you having to actually do anything except possibly authorize new permissions. So when we talk about 440 times shorter lead times, we're talking about the difference between being able to roll out a small, compact patch in 2 or 3 hours, as opposed to having to wait for it to actually be delivered 6 months after it was initially reported. And finally, and this really goes hand in hand with what I've just said, we are 46 times faster or more frequent deployments. Again, now we're going from a deployment every 2, 3, 4 months to a deployment every day, 2 days, 5 days, and we're able to roll these things out and delight our customers so much more quickly because we have this DevOps and Agile mentality now that has really informed our entire software development lifecycle. So what does this really buy us? Well, we want to ask ourselves, if I had 10% more engineering time because I've got fewer failures, because I've got less unplanned time for my developers and for my operations folks and for my testers, what could I actually do with this extra time? Well, the first thing I can do is I can experiment more and release with fewer bugs, because now my testers are going to be automating their tests as opposed to having to manually run through their tests. And so they're going to test more. They're going to catch more bugs. They're going to be included in that feedback loop that we talked about in that right to left thinking. The second thing, of course, is we're going to invest in the future quality of our software. Not only is our testing going to be different, but we're going to maximize automation. And so I'm going to be able to not only develop, but I'm going to test and I'm going to deploy, and that's going to be as automated as I can possibly make it. And what my 10% more time means for operations is they can focus on things like, how do I build new Docker containers and which are quick to spin up? How do I allow for spinning up a new virtual environment, a new virtual machine? If anybody who's gone on and used AWS or Azure knows how easy it is for you to go in and spin up a new environment. It's a couple of clicks, and within a minute or 2 minutes, you've got a whole virtual environment that you can work in. And that's because Amazon and Microsoft are investing in that kind of automation. Think about what it would be if your company, for your own systems, had that kind of automation, and all your developer needed to do if they needed a new test environment was click a few buttons, wait a minute, and now they've got a whole new test environment that they can work in that matches their development environment. And then, of course, we get all these people together and we start to look at how do we improve our market position. How do we improve our customer satisfaction? How do we lower our costs? These are, of course, all the bottom line kinds of things that we're concerned about. And then once we have 10% more time to actually think about the competitive edge, we're going to get out ahead. And the guarantee I can make to you is if you're not doing this, your competitors are, or your customers are expecting it because they see other people getting those kinds of benefits. You need to get those benefits also. So before we turn to, okay, what are the steps to get to DevOps, I just want to put in a quick plug that we at RightStar do what's called a DevOps simulation. If you've got middle managers, if you've got senior managers or C-level executives who are skeptical, who are not quite sure what DevOps means to them, or you've got teams of developers and operations folks, testers, support that are also skeptical and saying to you, well, this is just a fad, it's going to go away. If I ignore it, I don't need to worry about it. We do a full day simulation in which we try and demonstrate, not through slideware like a webinar like this, but actually by getting everybody up and involved in playing a very interesting game, but a very informative one through the course of a day. And we can do this on site, either at your location, or if you prefer to do it at a different location off site, we're happy to go wherever you are and give you the benefit of this simulation, which we find to be very powerful at helping to educate and inform and convince those skeptics in your company about the value of everything we've talked about. Okay, let's move on to talk about how do you now get to DevOps. There are three key pillars that I want to talk about: culture, practices, and tools. So let's go ahead and start with culture. You need, and this is the biggest takeaway I can give you today, is you must build a culture of collaboration. The first thing you need to think about is shared responsibility. Your DevOps organization is a safe space where everybody shares in the wins and the failures. It is not operations fault. It is not the developer's fault. It is not the tester's fault. It is all of our failure or all of our success working together. This is a shared responsibility. Secondly, we cross-pollinate our teams. Our teams are not silos of developers, operations, tests, support, but they are cross-capability, cross-talent teams. We want diverse teams that bring in different points of view, different professional experiences, so that we understand not only what we do, but how what we do affects everybody else on the team. In some organizations, they will go so far as to rotate people between different teams, at least in the sense of an internship type of trainee kind of way. So a developer actually sits on the service desk and fields the calls when his or her new release came out, so that they can actually experience what the support team experiences. Your operations folks may actually sit with a tester and learn what does it mean to do the testing and why is testing as difficult as it is. They need to understand this, and they need to participate within the team, giving their input so that everybody understands what's going on. We encourage transparency. Information is not power. Information held to your chest is useless. We want people to provide as much information as possible in a way that is as transparent and easily absorbed as possible. It is there when you need it. And so we encourage the transparency, we encourage the proliferation of information, but done in a way that makes it useful to the people who need to consume it. We're going to talk about that more as we get into tools. Finally, do we talk to each other effectively? Do we communicate in ways that we actually hear what the other one is saying to us? Atlassian has developed a set of health monitors for your teams, where you can start to look and see, does my team suffer from any number of various ailments, if you will, and what are some of the plays, what they call plays, that you can run? These can be games, these can be exercises, these may be new habits or new approaches. They've got a whole website devoted to helping you improve the quality of your teams. And I highly recommend that you take a look at that when you have a moment. Let's talk about practices. The practices behind DevOps, again, there are three of them we want to focus on. The first one we talked about, which is Agile. You must be Agile to be DevOps. You cannot be in a waterfall environment, because a waterfall environment reinforces the notion of silos, that once requirements is done, requirements no longer has any skin in the game, they're finished. Now development goes on, and so on through the life cycle. We don't want that kind of thinking. We want the thinking that we are fast, we are lean, and we are all in this together, and Agile helps to promote that idea. The second is the distributed version control system, and that's implemented through Git, which is free software that's available on every platform you can name. And why is that important? Distributed version control, which is a whole nother webinar we can get into, but the key thing behind it is that when we allow our developers and our testers to work in a sandbox environment, That is to say, they can make changes to the code and keep their changes under version control without affecting anything else. It gives us much greater control over the source code. It allows us then to much more carefully manage what we are releasing out to the next step in the process. And so developers can work on lots of different things in their own distributed environment and then only hand off what's really ready to go to test, and they can manage that and keep it very clean. So we strongly recommend the use of Git as the way to vastly improve your development process, your source code process. And then finally, and this is really the big piece, is the continuous integration, and we could add to that continuous deployment. That's really automation. Automation. We want to automate the building of our software, the testing of our software, and the deployment of our software. And to the extent that we can automate those three pieces, it vastly improves our ability to actually go through the software development lifecycle from requirements to actual deployment. We're going to automate all three of those. We're going to use some tools to do that, and we're going to talk about that in a moment. And so finally, we're going to get into the tools, and we're going to take you through quickly the key elements of the DevOps lifecycle. So here's our DevOps lifecycle. We're going to start in the upper left with the planning. We're going to plan for what it is we're going to do, and then we're going to build it. And we want what we plan to be small, compartmentalized units that can be built quickly. Because then what we're going to do is we're going to run it through continuous integration, which is build it, which is the actual building of the software. If we need to do compilation, if we need to bring in other artifacts, whatever it may happen to be to build out that particular software, we're going to do that in an automated fashion. We're going to run it through automated tests to the highest extent possible. And then we're going to hand it off for automated deployment. We're going to deploy it into an environment with as few touches as possible. That allows us to operate this software, whether we're operating this software for a week or for a year. We want that to be as smooth and as low touch as possible. And then we're looking to get continuous feedback from every part of the team, from support to operations, testing, development, and requirements. What went well in this cycle? What can we do better? And what things are we going to do differently the next time? And that takes us back into planning. So that's our DevOps cycle. Let's talk a little bit about how Atlassian helps to enable this. Again, starting in the upper left, Atlassian has a product called Confluence. Confluence is our documentation and information sharing system where we build out the requirements that we may have for the software. We discuss that. We can have attachments. We can put in screenshots. We can use that to make the information as widely available to everybody who's a stakeholder in our planning environment. And then we use Jira Software as the place where we start to think about what is our release going to look like? What are the key stories that we are going to want to put into this next release? And we plan that out. In the build phase, again, we use Jira Software because that's our project management. That's our software project management tool that tells us what's the prioritization, how long is this taking us, if I need to have a conversation about this requirement because I didn't understand it well enough to build it, or there's a key learning that I need to get everybody involved in, Jira Software is the place that I do that. Bitbucket is my Atlassian front end for Git. I'm going to show you examples of all of these, but Bitbucket gives me that front end to that distributed version control where I'm going to do check-ins and checkouts. I'm going to do code reviews. I'm going to use that in order to manage all of my branching. And then I use Bamboo for continuous integration and continuous deployment. Bamboo is the orchestrator for how I build, how I run my tests, and how I deploy, and what I'm going to build, test, and deploy. And it's going to draw all that out of Bitbucket plus the plans that I build in Bamboo. I'm going to deploy that. Again, I use Bamboo to deploy it, and I use Jira software. Remember, Jira software is where I'm storing all the list of things that need to be released. Jira software is actually going to communicate to Bamboo and say, now it's time to deploy, and here are the 15 stories that need to be deployed. And Bamboo is going to be smart enough to go to Bitbucket, which is where the source code is, pull it out, build it, test it, deploy it. We go to operations. We have Jira Service Desk, which gives us that service desk, which enables our agents, our help desk agents, to work with the customers to move a ticket from open to close as quickly as possible. And Confluence, remember, that is my document management system. Confluence provides me with the knowledge base into Service Desk, and that's where I'm going to publish my knowledge base, both for my customers so that they can do self-resolution, so they can fix their problem without me having to do anything else. And it's the place where I'm going to provide all the run books, all of the troubleshooting guides, all of my how-to guides that are going to help operations, service desk support, as well as my testers and my developers and my requirements people to make information transparent. That's how we're going to make all this information available and do it in a way that is well managed and curated so that we get the right information that we're looking for. I've got Status Page. Status Page is a product that is web only, and it's web only because it is where you publish to your customers, your stakeholders, and anybody else who needs to know what is the status of your environment. And the reason it sits on the web is that it's 5 nines available, and if your network goes down, if your access to your web server goes down, well, Status Page is still there, and you can publish something right on Status Page that anybody who subscribes and wants to know about this alert will know, hey, our web page is down, that's why you can't even get into us, but Status Page is going to be there. One piece that I'm missing from this, I need to add in, is OpsGenie. OpsGenie also supports operations. It's the place where it's going to pull in all the alerts and alarming that may come in from various locations, and it will give you the ability then to escalate and notify key personnel when they need to swarm on an incident. It's going to let people know that something has happened and that they need to look into it. It has escalation paths and various rules for doing all that. So that's the Atlassian ecosystem. I'm going to move fairly quickly through the rest of this because I don't want to go over too much in time, but I do want to make the point that all of these are Atlassian tools. And by the way, Slack is there because Slack is now, there's a partnership now between Atlassian and Slack for real-time communications. And so they encourage you to use Slack, and they've got a lot of things built in to support Slack specifically. But you are not by any means required to be entirely Atlassian in order to be DevOps. As you can see, we've replaced each of the different pieces with other tools that you might want to use. You might want, for instance, to use Microsoft Office and SharePoint as the place where you do your planning. You might want to use a GitLab or a GitHub for your source code control instead of Bitbucket. You may want to use some of Jenkins for the builds, and some of the other kinds of environments, Splunk and Datadog, for instance, for our operations and so on. So DevOps is not about the specific tools that you use, but looking at tools that will allow you to be agile, to have the distributed version control, and to automate the whole process. Okay. Let's go ahead and finish up. We're going to spend the next 5 to 6 minutes looking at a case study, if you will, of how DevOps works in an Atlassian-supported environment. So let's go ahead and look. We're going to start off, we've got a system that's already been deployed and an incident occurs, and I'm going to change this from HipChat to Slack, but this comes in from our instant messaging system that something has happened and Sam, who's our ops engineer, needs to look at it. And Sam is being notified by OpsGenie because OpsGenie is actually catching all that. And what happens is, in this case, PagerDuty is the thing that's come in and has triggered an alert that's gone out, and now my team is going to be alerted that something needs to happen with this software. In this particular case, we're dealing with a problem that there seems to be slowness happening on my web server. And Sam is going to come into Jira Service Desk because Sam is an agent, and it's going to create a ticket. The performance on cluster node 2 is degraded, and here's the ticket that Sam is going to create, and this is how I'm going to track that the issue is going to be addressed in a timely fashion. This goes out to Sally Developer. Sally Developer gets notified, hey, there's a problem going on with cluster node 2. I need you to do something and help me out to fix this problem. So what happens? Sally gets into Slack and gets the rest of the team together and says, hey, we've got this problem. We got to figure out what we're going to do about node 2. What should we do about it? First we're going to do is we're going to send out a notice to status page, and we're going to let everybody know, hey, we're investigating the issue. We know about this. Please don't open any more tickets. And what we want to train our users, our customers, our stakeholders is whenever they have a question about something happening in our system, first look at our status page and let us know whether or not they should see it here. We should be telling them about the problem as opposed to them telling us. Okay, so status page is where we let them know that the incident is happening. Simultaneously, we're going to go into Confluence and we're going to look and say, hey, is there a troubleshooting guide or some other information in Confluence that tells us how we should be fixing this problem? And in fact, in this case, we found something, and what it told us is we should simply turn up another node, which will take some of the load off of node 2, and that's what we do. So we've swarmed the problem, and we have addressed it. In the meantime, Sally is going into Jira Software and opening up a ticket to say, hey, I've got a bug and this should be fixed. This is maybe some technical debt that is causing a performance problem, and we really should get in there and fix, in this case, fix the cache issue because it's causing performance problems. So we go ahead and we add it into our backlog and we put it into Jira Software. Then, just to finish out our incident, we do a postmortem. This is our continuous learning, and we ask ourselves, what did we do well? What can we do better? And in this particular case, as you can see, there we go. We're going to use Confluence as the place where we're going to store our postmortem. And we've got a template that Confluence comes bundled in Confluence just to help us ask the right questions. What do we do well? What can we do better? And finally, what actions are we going to take to improve our performance in the next round? Okay, that's our front end. That's our incident. But now we're ready to go and fix this problem. So Jennifer comes in, looks at Jira Software and says, hey, there's a problem. It's number 67. I'm going to go ahead and assign it to myself, put it into progress. I'm just using a Kanban board here. So you can see it's in my current sprint, and I'm going to go ahead and work on it. I'm going to create a branch. That branch is going to be created in Bitbucket. Here's my view of Bitbucket. This tells me that Jennifer created a branch, has done some work, and has issued a pull request, which is really just a request for a code review and then to merge this into the main trunk of this release. Okay, this has been done. Now Bamboo has gotten a message that says, hey, I want you to go out and build this code. As you can see, it gets rebuilt. Everything got built fine, so it's green, which means that it's successful, and I know my code can be built successfully into the main branch. So it goes back to Jira Software, and Jira Software is automatically updated to show me there were 2 branches on this particular issue, 8 commits, 2 pull requests that were merged, and 4 builds, and the last one was successful, as you can see by the green check mark. All of this is due to the tight integration between these tools that Atlassian delivers. So now John, who's our release manager, says, okay, I'm ready to go out and release some software. I'm going to look in Jira Software, and here's a list of all of the software that I'm ready to release. I look at it, I make sure that it's all what I want to release, and I go ahead and I say to Bamboo, release this software. And Bamboo is smart enough to know where to get the source code, which branch to pull it from, how to build it, how to run its tests, how to deploy it, and then it goes out and it deploys it into the environment. Now, one thing I want to make sure that we raise is important about thinking about Atlassian is how do you expand these tools to scale? Often you'll find the Atlassian tools come into your organization through a small team that has heard about it and realizes that for $10 they can actually purchase a license to the tool, install it on an inexpensive server and run it for their team. But now you want to expand your tools to the enterprise. And that's where Atlassian now has what's called Data Center. And Data Center allows you to have multiple nodes, Jira software, Jira Service Desk, Confluence, Bitbucket, Bamboo can all be deployed in a data center environment where you can have multiple nodes. That gives you high availability. If one of those nodes goes down because it ran out of disk space, it ran out of memory, or you just need to take it down to new maintenance, the other nodes are still there to run. And in fact, you can have now in data centers 0 downtime upgrades. So if you've got mission critical operations, you can upgrade the software without taking it out of service at all. And so you can have better than 5 nines availability for this software. Of course, you can add multiple nodes, giving you performance at scale. You can continue to add node after node behind a load balancer, and so your users simply see that their performance doesn't suffer because you just run up a new node. And that then gives you that instant scalability to be able to handle the largest organizations, the largest enterprises, and allows you then to have that spread. And today, Data Center now supports content distributed networks in which you can deploy the software if you are an international organization with development teams, say in India or China or in Eastern Europe. You can have these deployed locally to them so that they don't have any of the network lag and performance issues that you would have if you have to deploy everything in a single centralized true data center. Okay, let's wrap up. Just a few things to reiterate. You're going to get more builds. You're going to increase the number of builds per month that you're able to do because you're automating, because you're moving faster, because you have smaller releases. And that allows you to have greater velocity in deploying your changes, and it's going to allow your people, your developers, your requirement people, even your testers and operations to work more independently because they don't have to be so tightly tied to everybody across your organization. We talked about culture, how important the culture is, and it's a way of thinking. It is not just a tool set and a set of processes. It is a way of thinking that we are in this together and we are all going to succeed together. We're going to be faster and smarter because we've automated. We're going to have fast feedback loops so that we are continuously understanding how we can get better, what went wrong, and how do we fix it. And we're going to prioritize because we're going to have much less unplanned work that we need to worry about. And so we're going to get that 10% boost in engineering time where people really can plan out the good things that they want to do as opposed to having to constantly put out today's fire. Okay, quick plug for RightStar Systems. We are recently we became a platinum partner of Atlassian. I will update that for the next time. But as a platinum partner, we are at the highest tier of support for Atlassian products. We are also a BMC partner. We do a lot of work in various BMC tools. And as you can see, we have been awarded in a number of areas. And perhaps one of the proudest accomplishments is that we were awarded the National Capital Business Ethics Award as a small business working in the DC area, particularly with government organizations, but with lots of organizations in the area. We're very proud of that ethics award. If you want to get in touch with us, we have lots of ways. Of course, www.rightstar.com is the easiest way for you to go ahead and find us. We have a phone number and sales@rightstar.com if you want to email us for more information. Okay, so with all of that, I'm going to stop sharing my presentation. I'm going to look and see whether we have any questions that may have come up during the session. let's see.
Yeah, there are a few questions here. I can read them to you.
Well, yeah, I'm just opening it up. Okay, yes, go ahead and read them to me.
Can you explain the automated testing a little bit?
Automated testing, yes. So what we want to do is we're writing scripts, and there are a number of different ways we run tests, and there are test harnesses out there like JUnit and PYUnit and others that will automatically run these tests, and they can be run either as, if we're writing Java code, just to use that as an example, we're going to use a test harness called JUnit typically. And JUnit is a framework in which my developers or my testers write Java code that will exercise all of the different Java components and function points that have been written. Going at a slightly higher level, I can go out and get any number of automated test tools that will allow me to do GUI types of testing, where I automate the clicks, the data entry, and I can then compare what happens next to what I expected to actually happen. Am I actually getting the right result or the error that I expect from doing that? And these are all automated suites. And then what I can do is I use Bamboo to execute that automated suite. And Bamboo can then parse all of the output, the error output from that, and tell me right away whether or not I have succeeded, whether those tests have passed or not. So this is automating my tests is really critical to reducing the time it takes to go from development to operations and deployment. I'm hoping that answered the question.
Great. The next question is, where is security in this process?
Oh, that's a great question, and the answer is that in fairly recently we've been started to talk about DevSecOps, and we've put security into the middle of that. But in some sense, to me, that it's not necessary to necessarily put security that way, but we expect security to be part of the team. We expect that at the outset, our security folks are telling us what security tests are they going to be running that we must pass. What are the requirements that they've put onto this? What perhaps are they going to allow us to deploy in terms of a new operating system or a new tool or a new environment that makes sure that they are meeting their security requirements? And so I think it's a great question, and the answer to that is we absolutely want the security as part of our DevOps team. We want them engaged and to participate from beginning to end.
In addition to that question, what about security testing?
Again, security testing there's a whole series of tools that are out there. I'm not familiar with them as much as I am with the code testing tools, but there are security testing tools out there that will allow you to automate that security, to automate that piece of it, and you can run those as well as part of your testing. You can decide when in the process is it most appropriate to run those tools? Do you run them on every time you commit the code? Maybe not, but maybe what you do is you do it every time you merge into the candidate release branch. You automate the running of those tools and make sure that there's no fallout. Often running those tools can take quite a lot of time, and so you want to make sure that you're doing it at an appropriate time in your development process.
Sounds good. One last question. Can we use Jira Service Desk in the same manner as Status Page?
I'm sorry, ask me the question again.
Can we use Jira Service Desk in the same manner as
Status Page? They really aren't the same thing at all. Status Page is an announcement platform. It's a platform where you're going to announce to people what is happening, whether it's an incident that you're aware of and are working on, or it's planned downtime, for instance, to announce that you've got a maintenance window coming up and people should be aware that they need to log off. That's really the niche that it serves. Jira Service Desk has the ability to place a banner notification on the portal, but you don't have the same things in status page, like the ability for your customer to subscribe and get those alerts. They would actually have to come into your portal to see it. And that's, it's not as effective as I think status page. But if you didn't want to go to a full status page, yeah, you can use Jira Service Desk to announce, again, put that announcement as a banner onto your portal and say, we're aware of this incident. The advantage of using status page is if you've got 25 or 30 systems, you aren't having to put 25 or 30 banners up, and it allows your user, if they're having a problem, they can come into the status page and see that you have proactively said this system is up. And status page can take automated information from systems. It can actually publish performance and uptime information on an automated basis. And so that becomes a much more reliable source of information than relying on people to put up and remove banners from a Jira Service Desk.
Great. Okay, that's all we have.
Okay, did you want to announce the winner of the book?
I have. It was Kathleen Veach. She won the DevOps Handbook. And if she could send me her mailing address to me at valerie.wilson@rightstar.com, I have that in the chat window, we'll get that right out to her.
Excellent. Well, I really appreciate everybody being on this webinar. If you have any questions, please feel free also to reach out to me. I'm derek.fields@rightstar.com, and I hope that you have a great rest of your day.
Thanks, Derek.
Thank you.